This is Radhakrishna, lecturer in computer science, Chamu Degree College, Palapallu. In our previous session, we discussed about requirement and requirement engineering. In that session, we discussed what are requirements, how to gather these requirements from the client, and how to analyze them, and what are the techniques to gather requirements, and what are the problems that we may face while gathering requirements. And we also discuss the feasibilities, different types of feasibilities, all the topics we discussed in our previous session. If you follow all the sessions which already completed, you'll get a clear understanding what is software engineering. In the first session, we discussed the different stages of software engineering. And in the continuous session, the next session, we discuss each stage in depth. So, you please follow all the sessions carefully, then you'll get a clear understanding what is software engineering and what are the steps you have. And in the remaining sessions, we'll discuss each step in depth. So, you please follow all the sessions carefully. Now, in this session, as a continuation for the previous session, as a continuation for the previous requirement engineering, here I'm going to explain some concepts that are requirement analysis and some techniques, fast use cases, requirement analysis principles. All the topics we'll discuss in today's session. In this, first of all, let us see what is requirement analysis. Software requirements analysis is the first topic. Analysis. This software requirement analysis is divided into several tasks. So, what are the tasks? Here, what is analysis? Analysis is nothing but we have to examine that. We have to examine the requirements and we have to purify. Finally, we have to get some output. So, this requirement analysis consists of the following tasks. Let us see what are the tasks we have. The first one is problem recognition, is the first one. First task to be performed is problem recognition. And the next one is evaluation and synthesis is the next task we have to do. And the third one is modeling is the third one. And next one is specification. And the last one is review. These are the activities we have in requirement analysis. Problem recognition, evaluation and synthesis, modeling, specification, and review. Let us discuss each one. First one, the problem must be recognized clearly. The developer must recognize the problem to be solved in this project. For that, he have to analyze, he have to examine all the transactions of the client organization. Then only he will get a clear understanding what is the problem, what are the tasks, what are the different complexities inside the problem, inside the organization. Then he will understand the organization nature. So the developer need to examine the organization clearly. He have to examine all the internal components, all the internal departments and their transactions. Then, with the help of all these examinations, he will get some problems. He will identify some problems. Like that, first he have to recognize problems in the first stage. And in next stage, evaluation. The developer need to evaluate all the problems. And synthesis means you have to group all these. You have to maintain all these problems as a group. So in the second stage, he have to evaluate and synthesis. And after that stage, the developer need to create a model. There are so many models are identified. Experts identified so many models to solve several problems in this requirements gathering and requirement analysis. There are so many models available related to requirement analysis. So, with the help of these models, the developer need to create a model. He may use any one of the identified, any one of the proven model. The developer may use any proven model to develop a model for this requirement. And the next one is specification. You have to specify all the identified requirements as a document. All these identified requirements and this modeled output, this modeled report, all these must be documented as a specification. Finally, it must be reviewed for correctness. It must be re-verified for correctness. So these are the activities involved in software requirement analysis. Please let us see all these tasks that we have in requirement analysis are first one is problem recognition and evaluation and synthesis, modeling, specification, and finally review. These are the activities we have in requirement analysis. One more technique now we are going to discuss that is called as FAST, F-A-S-T. What is FAST? Software engineers and customers will have a mindset. That is what with us and them mindset they will have. With this, some experts developed some techniques how to gather requirements. In this, FAST, FAST is one of the technique. Facilitated application specification technique. Facilitated. FAST means facilitated application specification technique. Facilitated application specification technique. FAST. With the help of this technique, the developers will gather some other requirements and they will get much more clarity on the requirement. This fast is a technique which helps the developer and customers to get clear understanding, to clear idea about the project to be developed. In this technique, we have to use some rules. First one, a meeting must be arranged at a neutral area, in the sense which is not related to the client or which is not related to the software engineer. At a neutral area, a meeting must be arranged. And we have some rules, we have some protocols that must be followed in this fast technique. So, what are the rules to establish this fast? That we'll see one by one. First one, an agenda must be finalized. What is to be discussed in this? What are the concepts will be raised? What are the concepts will be discussed? How to gather requirements? Like that, an agenda will be designed and it will be circulated to all the participants of the meeting, all the participants of the fast meeting. And next one is a facilitator must be appointed. A facilitator must be there who will organize the meeting. That is the second one. That facilitator will control the meeting. That facilitator will avoid deviations from the discussion. So, a facilitator is also required. And next one, the definition mechanism must be used. For everything, everything must be defined in clear. That is the third one. So, the goal of problem, what is the goal that they have to achieve? What are the company requirements? Which is possible, which is not? All these must be finalized prior to this. In this, the proposal system must be clearly written and it must be circulated to all the participants of the first meeting before conducting the meeting. With that information, all the participants of the meeting, all the participants of this first meeting will raise their ideas. They will give their ideas as a list individually. That list must be gathered from each one. And these lists may contain repeated ideas. So, in all these lists, repeated ideas must be removed. That is what redundant ideas, redundant or repeated. Some ideas will be repeated by different participants. So, these must be gathered and by watching, by observing all the list, we have to eliminate the repeated ideas. But it must not be shortlisted in the sense no single idea, no unique idea must not be removed. All the ideas must be maintained. And finally, a list will be created with all the ideas of the participants. On all these, we have to finalize, we have to decide what to be done in the project. Which is not important, which is important. From the finalized list, the developer must recognize which is important, which is not, which can be used. Like that, you have to finalize a final list. Like that, by creating a meeting at a neutral area between the customer and client side, the customer side and the software engineers, with the discussions, by expressing their ideas, we can gather some more requirements and we can give clarity on what will be done in the project. This is another technique which is called as FAST. In this, what we discussed, first one, a meeting must be conducted at a neutral area and agenda must be finalized. So what is to be done in the meeting, what is to be discussed in the meeting, agenda to be finalized. A facilitator must be arranged who can control the meeting and the definition mechanism must be used to define everything. The goal of the project must be finalized A list must be gathered from all the participants of the meeting and it must be verified. A final list must be generated. So procedure. This is the process to conduct the meeting fast. Facilitated application specification technique. One more concept related to the requirements that we have to discuss is quality function deployment. This is another technique. What is quality function deployment? This is a quality management technique that translates the user given requirements into technical form which is used for software development. The user may give his requirements as per his knowledge and these must be translated, these must be converted to a technical form. This technique is called as quality function deployment. In short, it is called as QFD, quality function deployment. This technique will translate the user given requirement at the time of meeting between the client and the user. They will give some requirement. So this quality function deployment technique is a quality management technique which converts the user requirement into technical form. In the previous session, we discussed different types of requirements. We categorize the requirements as functional requirements and non-functional requirements. We also categorize the requirements as must have, should have, and could have. Now, I am going to categorize the requirements again in three types. This quality function deployment identifies requirements in three models. This can identify requirements as three categories. The first one is normal requirement. That is the first category which will be identified by QFD. The second one is expected requirements. And the third one is excited requirements. Let us discuss each one. Here we categorize it again. That means this QFD, quality function deployment, recognizes requirements as these three types: normal, expected, and excited. Let us discuss each one, which is normal and which is expected and which is excited. Normal requirements, the objective and goals that are stated for a product or system during meetings with the customer are called as normal requirements. At the time of meeting with the customer, some objectives and some expectations will be identified. With the discussion of the client, the developer will identify some objectives and goals, some expectations. So all these will fall under normal requirements. If these requirements are present, then the customer will get satisfied. If these requirements are absent, the customer may not get satisfaction. That is, those are called as normal requirements. And the next one is expected requirements. These are implicit to the product. Without these requirements, the product is not a complete product. The customer may not get satisfaction. We can't say that this is a complete product. If these expected requirements are absent, then we can't say the product as complete. The customer will be in dissatisfaction. So those requirements are called as expected requirements. And excited requirements. What are excited requirements? These requirements are beyond the customer ideas, beyond the customer expectations. The customer may not give these requirements. He may not idea about these requirements. But with the experience and knowledge of the developer may introduce some other requirements and which will give more satisfaction to the customer. So these requirements are called as excited requirements. These will be generated with the help of, with the knowledge of the software developer. So these are unexpected. The customer never expects this. The customer don't know about these requirements and these facilities. But if these are present, then the customer will get more satisfaction. Like that, requirements can be classified. That means this quality function deployment mechanism will identify requirements as normal, expected, and excited. This is about quality function deployment. Use cases. Now let us discuss about use cases. After performing meetings with the customers, with the clients, the developer will get some requirements. With the help of these requirements, the analyst must identify who will play this developer system. In future, who will use the system. Like that, first of all, the analyst must identify who will play a role in utilization of the system. So, if the persons are identified, then with the help of that, the developer will create different use cases. That means, what is a use case? Means how persons interact with the system, how the persons use this system. It can be designed with the help of use cases. Before going to use cases, first the analyst must identify actor. Here, actor is different and user is different. These two are not same. It's very important to note that actor and user are not same. So what is the difference? It's most important that how an actor is different, it must be identified. And here, an actor is an external person to the system. He is not internal. Of course, he may use the system, but he is external. So, here, an actor represents, here I am going to explain, I am going to define the term actor. An actor is a class or external entity that plays just one role in the system. He is external, he is a class, he is an external entity of the system and he will just play a role. He is not same as ordinary user. Okay, once actor is identified, then use cases can be developed. How the actor interacts with the system, how he utilizes the system. Some cases, some use cases will be developed. While developing these use cases, some questions must be answered. What are the questions to be answered while developing use cases? One by one, we'll discuss. The first question that must be answered is what main tasks and functions that will be performed by the actor? What are the main tasks or functions? First one is main tasks and functions that will be performed by actor. It must be identified. What are the tasks? What the actor will do? What are the tasks and functions that the actor will perform? That is the first one. And what is the information the actor acquire, produce, and use? The second question, we have to place what before all the questions? Acquire, produce, use information. What is the information that will be acquired, produced, and used by the actor is the second one. And remaining questions are right here. Next question to be answered. Third one. Is it necessary to inform the external changes to the actor? If any changes happen, if any change is performed external to the system, outside the environment, is it necessary to inform about that change to the actor? That is one more question we have to discuss, we have to answer. That means inform about, that is the third question. About external changes to the actor. Is it necessary to inform about external changes to the actor? That is the next one. And one more question is, what information the actor desires from the system? So, while designing use cases, all these questions must be answered. What are the functions that the actor performs with the system? Is it necessary to inform external changes to the actor, which is happen outside the system? And what information the actor desired from the system? Like that, all these questions must be answered. Information regarding all the questions must be gathered. And with the help of all these answers, then the analyst will create use case diagrams also. So this use case diagram will explain, will give clear understanding to the developer what the actor will do with the system. What are the operations will be performed by the actor with the system? What are the requirements of the actor from the system? All these will be explained with the help of these use cases and use case diagrams. This is another important concept of requirements. Software analysis principles. There are some principles defined. What are the principles that we must follow when designing a software model? Let us discuss one by one software analysis principles. The first principle is the information domain of the problem must be understood. It must be clear. It must be represented and understood clearly. That is the first rule that we must follow. Another rule is the functions that the software is to perform. What are the functions the software is going to perform? This must be defined first. What are the reports it will create? What are the transactions it will perform? So, what are the functions that the software will perform? It must be defined first. And the third one, the behavior of the software. How the software behaves. It must be clearly defined. And the fourth one is the analysis model must move from essential information towards implementation model. Actually, the analysis model will show us the entire layout, the overall layout of the system. The analysis model will give us an information what to do, what are the elements you have. This will give a overall idea about the software that we are going to develop. It must move from this stage towards the implementation model. That means we must able to convert this analysis model to implementation details. That is another principle that we must follow. And in this analysis principles, we have to follow one more principle. That is what? Understand the problem domain. Understand the problem. Before we begin to create analysis model, before beginning analysis model, before beginning the design of analysis model, first we must understand what to do, what is the system. And another principle is we have to develop a prototype. That prototype will give the user to understand what is going on. So we have to develop a prototype also. It can be understood by users. It could be understood by humans. So that is another principle. Here the principle is we have to create a prototype that can be understood by human or that could be understood by users. And another principle is record the origin of requirements. Record the reason for every requirement. From where a requirement will come, from where we will get requirement. What is the reason of the requirement? It must be clearly recorded. That is another principle. We have to use multiple views of requirements. Requirements can be viewed in so many ways. So here another principle is we have to view the requirement in different views. Not only a single view, we have to apply different views and we have to imagine these requirements as different views. And another principle is we have to rank these requirements. Ranking means we have to prioritize which is high priority requirement, which is low priority requirement, which is normal requirement. Like that, we have to prioritize. Finally, we have to work. Another final principle. We have to work to eliminate ambiguity. Ambiguity means which creates a confusion. Ambiguity is a situation. Ambiguous situation creates some confusion. So we must work to eliminate this ambiguity. Like that, by using all the principles, all these principles are designed to create a perfect, proper, successful analysis model. So with the help of all these principles, we can create a successful analysis model. Analysis model. This analysis model operates as a link between system descriptions and design model. This shows the functionality, the operations, and various elements of the system that we are going to create. Let us discuss elements of analysis model. An analysis model can be viewed as follows. Please study this diagram on the screen. This model contains first one scenario-based elements. First one is scenario-based elements. In this scenario-based element, we will have use case diagrams and user stories. That is first one scenario-based element. This is one element. And we have another one is there, that is class-based elements. In this class-based element, what we'll have? This contains class diagrams and another one collaboration diagrams. Class diagrams and these two diagrams will be used in this class-based element. And another element you have, that is behavioral elements. This shows the behavior of the system that we are going to develop. Behavioral elements. In this, we'll use sequence diagrams and state stories. That is next one. That is what? Behavior elements. And the last one is flow-oriented elements. In this, what we'll use? Data flow diagrams. These diagrams can be used to show the flow within the system. Data flow diagrams and control flow diagrams. Data flow diagrams and control flow diagrams. This is an analysis model. These are this analysis model contains, these are the elements. These are the elements of analysis model, which contains scenario-based elements, class-based elements, behavior-based elements, and flow-oriented based elements. We have to discuss each one. Which one which can be used for which purpose? First one, if you see scenario-based elements, in this we used use case diagrams. These diagrams, use case diagrams, user stories, these will be discussed in our next sessions. In scenario-based elements, we use use case diagrams and user stories. What is scenario-based element? This type of elements represents the system user. This type of diagram, this type of element will show you the system as user point of view. How the user will see the system, This element will give you the user point of view, how the system will be displayed. And scenario-based elements are case diagrams and user stories. These two are the scenario-based elements. And next one we have class-based elements. What are class-based elements? The object of this type of element manipulated by the system. The object of this one, actually classes means we will get objects. The object of this element will be manipulated by the system. At the same time, it defines the object, attributes, and relationship. What are the objects we have? What are the attributes that the object will have? What is the relationship between those objects? All these will be explained with the help of this class-based element. And another one is the collaboration is occurred between classes. Here, several classes will be used. In this, between these classes, there will be some collaboration, there will be some communication. So it will be explained in this class-based elements. And one more thing is, class-based elements are the class diagrams and collaboration diagrams. In this, we will use class diagrams and collaboration diagrams. So this is class-based element. That is the second one we have to discuss. And third one is behavioral elements. What is there in behavioral elements? In this, here we have sequence diagrams and state stories. Behavioral elements represent state of the system and how it is changed by external events. So it shows, suppose if the system is affected by external events, it will be displayed, it will be represented. So for behavioral element, what we can say is behavioral elements represent the state of the system and how it is changed by external events. That is behavioral elements. In this behavioral element, we'll use sequence diagrams and state diagrams. And finally, we have flow-oriented elements. What is this flow-oriented element? This flow-oriented element, this is the information flow. What is the information flow in the system? Through the computer-based system. What is the information flows through the computer-based system? From where the information flows and to where it flows. It shows how data objects and how data objects are transformed. Sometimes data objects will be transformed. So this also shows how data objects are transformed while they flow between various systems and functions. Sometimes data objects will flow from one area to another area, from one place to another place in the system. In this case, how these data objects will change. These will be explained with the help of these flow-oriented elements. In this flow-oriented element, we will have data flow diagrams and control flow diagrams. This is about analysis model and its components. Already we discussed some principles for analysis model. Now we are going to discuss about different rules while designing analysis model. The first rule is the model focus on the requirements in the business domain. The analysis model must focus on the business requirements, in the business domain. Here, the level of abstraction is high. That means, what is meant by abstraction? Means, we need not specify, we need not mention all the details. Just simply, we can represent essential details only. We need not specify all the details. That is called as abstraction. Here, the abstraction must be high. And one more rule that we must follow in this analysis model is every element in the model helps in understanding the software development requirements. The software requirements will be understood with the help of all the elements in this analysis model. And this model focuses on information, function, and behavior of the system. So all the elements in the system will concentrate on requirements, and it concentrates on it focus on information function of the system. That is another role. It must do, it must perform that activity also. And the third one is the consideration of infrastructure and non-functional model delays the design. If you consider the infrastructure, then it delays the design. That means, suppose if you want to use database, simply we have to use database only. We should not go for internal details, how the database functions are, how the database processes are. Like that, we need not go for all the internal details of the system. And the next rule is throughout the system, minimum coupling is required. What is coupling? Actually, this coupling and cohesion, these topics will be discussed in our next session. Here, I will try to give brief details about coupling. Coupling means the interconnection between modules in the system. A system contains several modules. So, interconnection between these modules is called as coupling. So, minimum coupling is required here. That is another rule. Coupling also must be managed. At the same time, another rule have the analysis model must give value to all the people that are participating in the system. To all the human, it will give value. The analysis model will give value. And the last rule is the analysis model must be as possible as simple. When the model is simple, then only we can understand it easily. Like that, by following all these rules, we have to design an analysis model. While designing analysis model, we must keep all these rules in mind. And related to analysis modeling, we have to discuss some other terms. Those are data modeling, data objects, relationship, cardinality, and modality. These are the terms we must know. First one, let us discuss first one, data modeling. What is data modeling? Analysis modeling starts with data modeling. So data modeling is the first stage in analysis modeling. Here, the software engineer defines all the data objects that proceeds with the system, and the relationship between the objects will be defined. In this data modeling, the analyst will identify the objects. He will identify the relations between those objects also. So that is called as data modeling. And next, what are data objects? Data objects means those are having some other extra details. Then you can call those as data objects. For example, if you take a phone number, this is a single value, so this is not data object. But suppose if you take a person will have name, a person will have phone number, a person will have address, door number, father name, like that. A person will have so many details, then that person will be an object. So it can be called as data object. So if anything is having some other extra details, then it can be called as an object. And relationship. Relationship is nothing but that is the relation between the objects. How these objects are interrelated. What is the relation between these objects? It can be explained with the help of relationship. And cardinality. These objects will have events, and each object will have number of events with another object. So how these events are related? How many events are related? There are different types of cardinalities. Those are one-to-one cardinality. You can call it as one-to-one, and many-to-one. That is another one. And third one is many-to-many. That is third cardinality. If one event is having relation with another event, then we can call it one-to-one. Suppose one person will have one phone number. Here the relation is one-to-one. And one-to-many. That means if one person purchases number of items, so here the item side is many and one person, that is one-to-many. That is one-to-many cardinality. And the final one is many-to-many. So here many events will have number of relations with many events of another object. Then it is called as many-to-many. Like that, the cardinality will be expressed. And modality. What is the modality? Modality is nothing but if the events are optional, then the modality is 0. If the events is compulsory, then the modality is 1. Like that, modality can also be explained. All these concepts will be explained in detail in our remaining session. Here, I am simply trying to introduce all the terminologies: data modeling, data objects, relationships, and cardinality and modality. So these will be discussed in our next topics, and some other diagrams already we discussed today. We use some other terminology, data flow diagrams, ER diagrams, like that we use some terminologies. So all the diagrams we'll discuss in next session.